Hello everyone, welcome back to math. This is our second class, and today I'm going to try to finish off the vocabulary unit because I don't want to spend too much time on it, but I still want you to know the terms that will be critical in math this year and in the future. So, as always, I will keep moving through these slides. Feel free to pause the video at any time if you need to. So let's get started. We're going to begin again with some basic formulas, all right? And these are things you should already know. I just want to put them in some context and give a definition. So an equation. An equation is a statement that the values of two mathematical expressions are equal. Okay. Of course, we use the equal sign. A couple examples. Of course, 2 plus 2 equals 4. We could flip this. 4 equals 2 plus 2. Seven times 3 equals 21. Okay, both sides of that equal sign are equal. 47 equals 90 minus 43. 10 equals 100 divided by 10. All right? Both sides of that equation are equal. The values are equal. The sum. A sum is the result of adding two or more numbers together. 2 plus 2 equals 4. All right? The idea here is that the sum of 2 and 2 is 4. 27 plus 15 equals 42. The sum of 27 and 15 is 42. 245 plus 366 equals 611. Again, the sum of 245 and 366 is 611. So if I ask you what the sum is, basically I'm asking you what is the answer. Now, to the real basics, which you know, but I do want to add some context here. Addition. To add something. All right, this is just adding something to something else. The symbol we use is that little cross, plus symbol, whatever you want to say. And an example is 2 plus 2 equals 4. All right, easy. We're taking 2, we're adding it to 2, we're getting an answer. All right, adding something to something else. Easy peasy. Subtraction. Taking one number or amount away from another. We also call this minus. The symbol is that little dash line or a minus symbol. And easy peasy. 6 minus 3 equals 3. We're taking 3 away from 6, and of course we get our answer 3. Next one, multiplication, or to multiply. And this is to add equal parts. That may sound a little confusing, I'll be honest. So let's break this down. All right, we've got our symbol, which is an x, to multiply, multiplication. And here we've got an example. 2 times 3 equals 6. Right? Multiplying 2 and 3, getting 6. Now, getting to that definition, to add equal parts, let's break it down like this. All right? We can consider it like this. All right? 2 plus 2 plus 2 equals 6. We're taking 2 and we're adding 3 equal parts. All right? Or you could even consider it like this. 3 plus 3 equals 6. All right? Our part is 3. We have 2 equal parts. We're getting 6. All right? So, again, if I ask you to multiply or to times a number, remember that it is multiplication. Next, for our most basic of formulas, is division. This is to divide. And this is to break a group of things into equal parts. So again, we're working our way backwards from the multiplication piece, kind of like we discussed last class with our square and cube, square root and cube root, working backwards. Our symbol, of course, is the line with the dot above and below. And let's look at this. 6 divided by 3 equals 2. So, we have to consider we're breaking these group of things into equal parts. So, consider it something like this. Again, working backwards. 6 minus 2 equals 4. 4 minus 2 equals 2. So you see we've got those 3 equal parts, 2, 2, 2. That's why our answer is 2. Another formula that will come into play perhaps this year is an average. An average is the sum of a group of numbers divided by the number of values in the group. So, let's look at an example. So here we've got a group of numbers. Okay, we've got 4, 7, 13, 8, 19, 3, 22, 7, 15, and 6. All right, we've got a total of 10 different numbers. So, as the definition is telling us, it is the sum of a group of numbers. Okay, so let's add them together. All right, so we add all of those numbers together and we get 104. The second part of our definition tells us to divide by the number of values in the group. So again, we've got our group of numbers, and the total amount of numbers in the group is 10. So we are going to take our summation, all right, 104, divided by the number of values in the group of numbers, 10, and we get 10.4. So the average of that group is 10.4. Of course, these can vary. You could have a very large set of numbers, a very small set of numbers even, and it's just going to work the same way. Now, let's move on here to angles, all right? Angles are going to play a big part in this term when it comes to transformations, and next term when we are talking about more geometry terms and things like that. So let's get into it. First of all, an angle. An angle is the space, usually measured in degrees, between two intersecting lines. Okay, so the space between two intersecting lines. Two lines that come together. All right? So, first of all, here we've got our two lines. We've got AB and BC. And they intersect, they come together, and that space between the lines is our angle. I'm sure you know this already, okay? Now that angle is going to be measured in degrees. A full circle has 360 degrees, as I'm sure you know, all right? So keep that in mind as we move forward here. We will look at more angles and their unique characteristics. Now the vertex of an angle is the point or a point where two or more line segments meet. So you don't have to write all of these down, okay? But you see where those two lines meet in both of those examples. That is the vertex. That's essentially where we are going to measure the angle. So this is for two lines, but like it says, it could be more line segments. So think about a triangle, okay? A triangle is going to have three vertices or vertices. And again, we can measure each of these. It will tell us information. Now on to our specific angles. An acute angle is an angle that measures less than 90 degrees. Okay, remember our full circle is 360 degrees. An acute angle is less than 90 degrees. So you don't have to write all of these, all right? Just maybe one would do. So as you see, we've got a 45-degree angle, a 20-degree angle, a 65-degree angle. All right? They are all acute angles because they are less than 90 degrees. Now, if our line continues, we get to a right angle. A right angle is an angle that measures exactly 90 degrees. Exactly 90 degrees. There you see it. This is a right angle, and these are usually shown with that little square symbol, all right? Even if we don't have the numbers there, 90 degrees, if we see that little square at the vertex, we know it's a right angle. And we know that it will measure 90 degrees. Okay. So again, why I'm explaining some of these is because we're going to have to understand really the basics and then extrapolate them, or extrapolate this information we have to answer some critical questions as we go forward, okay? So it'll basically, in some ways, it'll be a big puzzle, all right? Taking this information and that information, pulling it together to complete the problem. Next, we have an obtuse angle. An obtuse angle is an angle that measures more than 90 degrees but less than 180 degrees. Okay, so this is critical. It's got to be more than 90 degrees but less than 180 degrees, because we know that we have a right triangle at 90 degrees, and we'll learn about another angle at 180. So a couple examples. Again, you don't have to write all of these down. Our obtuse angles include 145 degrees, 95 degrees, 170 degrees. Now, like I was saying, when we get to 180 degrees, we have a straight angle. A straight angle is an angle that measures exactly 180 degrees, or a straight line. Okay? So there are very defined perimeters for each of our angles, okay? Please keep them in mind. Now, once we move beyond 180 degrees, we get a reflex angle. A reflex angle is an angle that measures more than 180 degrees, but less than 360 degrees, less than a full circle. All right? So here we've got a bunch. Again, you don't have to write all of these down. But angles, again, like 255 degrees, 244 degrees, 248 degrees, 266 degrees, 192 degrees. All right? They're all reflex angles. More than 180 degrees, a straight line, but less than 360 degrees, a circle. Now, the last piece, and I know I'm zooming through these, okay? But we need to look at some shapes. First of all, when we talk about shapes, we also should consider congruence. Congruence is two objects or shapes that have the same shape and size. Okay? So essentially, two objects or two things that are the same. Now, when things are congruent, we will use this symbol. Don't know how to describe it necessarily. Two lines with a wavy line on top. All right. But I want you to consider this, okay? Here we've got two triangles. Triangle A, B, and C, and triangle D, E, and F. Now, as we're going to see here in a few minutes, both of these triangles have the same length sides, the same angles within them, all right? They are identical. They are congruent. So you see that symbol at the bottom, all right? Triangle ABC is congruent with triangle DEF. They are the same. Next, a parallelogram. A parallelogram is a four-sided shape with two pairs of opposite, congruent, or equal sides. Okay? So we've got two pairs of congruent sides. So an example is a rectangle. A rectangle is a parallelogram. And for this, we're going to focus on the area. Right? The area is base times height. So if we look at this, you see that we have a rectangle. We have two sides that measure 8 centimeters and two sides that measure 3 centimeters. Right? They're two pairs of opposite congruent sides. To find the area, we are going to multiply the base times the height. 3 centimeters times 8 centimeters equals 24 centimeters squared. Okay? Ladies, you see here, we have our unit, centimeters. And when we find the area of an object, we must use the square symbol. Here we have another parallelogram, all right? Now this is a little different. We aren't given the diagonal sides, but we are given the height, which is 8 inches. And the top, or the base, is 15 inches. So again, we're going to take 8 inches times 15 inches equals 120 inches squared to find the area. Okay? The key thing with the parallelogram, though, is that we have two pairs of equal sides. Okay? And I'm sure you know how to find the area of a rectangle or a square or a parallelogram. Okay? Base times height. That's all it is. A square. Okay, not to be confused with the earlier square. This is the shape. A square is a regular parallelogram where all sides are the same length and all angles equal 90 degrees. We have the same area formula, base times height. All right, here we're given an example, a square. All right, all of the sides are equal. They are 5 centimeters. And if you can't tell, all the angles inside would measure 90 degrees. Now, I didn't put the formula here, but I mean, I'm sure you can do this. The area would be 5 times 5, which equals 25 centimeters squared. Okay. All right, a couple more here. Okay, I know we're zooming through this, but I really want to get this done in one more class so we can get into the lessons. A triangle. Okay, a triangle is a 3-sided shape with straight sides and 3 vertices, right? The plural for vertex. Now, the important thing to note is the angles within a triangle equal 180 degrees. Okay, so all the angles inside of a triangle will equal 180 degrees. And this is going to tell us a lot, okay, as we look at some problems this year. Please remember that. Now, for a triangle, our area is half base times height. So here we've got a triangle that is 7 inches tall and 6 inches at the base, okay? So our formula is going to be half times 6, half base, times height, 7. So essentially, if we break this formula up or start to do it, it would be a half times 6, which equals 3. 3 times 7 equals 21 inches squared. Here we've got another one, all right? 4 centimeters at the base, 6 centimeters high. Again, doing the problem, half 4 times 6 equals 12 centimeters squared. Please don't forget those units. Finally, we've got 5 centimeters tall, 8 centimeters at the base. Okay. And again, excuse me, we can find this out, all right? A half 8 times 5 equals 20 centimeters squared. Now there are some specific types of triangles. All right, we have a right triangle. A right triangle is a triangle that has a right angle in it. Okay, a 90-degree angle in it. Like this. Okay. You see we've got our 90-degree angle there in the corner. And the rest can vary. Okay, it will depend on the other angles with what they are. All right. We also have an isosceles triangle. Isosceles triangle. This is a triangle with 2 equal sides and 2 equal angles. So here we've got 2 examples. All right, we see that we've got equal sides denoted by those little lines that cross the sides of the triangle. We will talk about that in a moment. But you see that because we have 2 equal sides, we have 2 equal angles at the opposing side of that unequal vertex. So from that vertex of 40 degrees, basically we're going to take 180 degrees minus 40, okay, that equals 140, and divide it by 2 because we will have equal angles, and we get 70 degrees. The same thing in the second example, 180 minus 70 equals 110 degrees, divided by 2 equals 55 degrees, to give us those opposing angles. Okay, an equilateral triangle. This is a triangle with 3 equal sides, and each angle equals 60 degrees. All right? Because our sides are equal, that means that our angles are going to be equal. Okay? So here we've got sides measuring 5. I don't know what the unit is there. It's not given. 5 centimeters, 5 meters, 5 inches, I'm not sure. So each side is 5, and each interior angle is 60 degrees. All right, last couple here. Hypotenuse. Hypotenuse is the opposite to the right angle in a right triangle. So what does this mean? Well, it means this. When we have a right triangle, the opposing line, or the opposite line from the right angle, is the hypotenuse. Okay. Now you may think, well, why are you telling me this? Well, sometimes we will need to use a formula to find either the hypotenuse or one of the legs of a triangle. So here we have our Pythagorean theorem. I know you are learning this or have learned this. The Pythagorean theorem is the square of the hypotenuse of a right triangle, which is equal to the sum of the square of the other two sides. So what does this mean? Well, our formula is a squared plus b squared equals c squared. So again, we've got our triangle with the two legs of the triangle and the hypotenuse. Again, a right triangle. And here, as an example, we're given a right triangle with sides measuring 7 and 8, and then we don't know c. All right, the hypotenuse c. So we're going to plug these into the formula. All right, so you see we've got a squared plus b squared equals c squared. We're going to put the two legs we know in there. 8 squared plus 7 squared equals c squared. Right. We will square those numbers. So 64 plus 49 equals c squared. 113 equals c squared. To find c, we will take the square root of 113. Okay? And then from there, we will find our hypotenuse. Okay? So again, we will be using this year, both in English and in your Thai math classes. So please keep it in mind. Last two, equal sides symbol. All right. Sometimes our problems will not give us all the information, but it will give us clues. An example is the equal sides symbol. These show which lines are equal. So we saw some examples earlier, all right, where we've got these little lines that go over our triangles. The triangle sides, I should say. They tell us those lines are equal. There we go. So it can be used for triangles singularly, right? Maybe all three sides are equal, like an equilateral triangle. Maybe two sides are equal, like an isosceles triangle. Or if we have two triangles, maybe it would tell us which sides among those two triangles are equal. And lastly, the equal angles symbol. These show which angles are equal. Okay? So again, this can be used among two triangles to tell us which angles are equal among them, or within one triangle, telling us which angles are equal and which is not. Again, all this information will help us to solve the problems we will face this term. So ladies, I know I went through this very quickly. It's a lot of information. Please make sure you get all of this information down on the paper and practice it, review it, make sure you know what it is, because we will see examples of these throughout this year, both in the first term and the second term. You will see them in your Thai math classes, so it'll be good to connect the English vocab words and definitions to what you see in your Thai math classes, but more importantly, you'll see this information throughout the rest of Mathiom and university. All right? So if you have any questions, please let me know. Hope you have a great day, and I'll see you in our next class.